Good afternoon, everybody. Thank you for attending. Barbara Spagnola here, Vice Chair of the WRF-CAC. And this is a special meeting today on December 17th. We're at the Morro Bay Community Center. It is 3 p.m. And I will notice that we have a quorum present, all members in attendance, and therefore the quorum is established. Call this meeting to order today. I'd like everybody to rise for the pledge, please. Look at the screen. Use your. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you. And since this is a special meeting and we have one item on the agenda, I'm going to hold off on public comment, a citizen's request for after the presentation, and then we'll can have our discussion as well as any committee member announcements after that. Okay? So if we could proceed, I will turn this special agenda item over to staff. This is the review of the concept design report for the WRF conveyance system.
Thank you, Barbara. Members of WRF-CAC for being here. We're here to present our initial findings for the concept design report and take input from the WRF-CAC. I'm going to turn it over to Eric Caceres, our program manager, who's going to have some brief opening remarks, and then we'll proceed on with a presentation from Waterworks engineers. Thank you.
Thanks, Rob. As Rob mentioned, we're here tonight to talk about the concept design report that's been developed by Waterworks engineers. Really, the goal tonight is to present the major findings that WRF-CAC will see in the draft report. We chose to come and do an initial presentation before we develop the draft report, finalize the draft report so that we could take your input in here tonight and make sure that that gets reflected in the draft document. So the city's been working with Waterworks engineers since November of 2017 as the designer for the lift stations and pipelines that will be used to connect the existing wastewater treatment plant to the new facility, the water reclamation facility out at South Bay Boulevard. This is the Waterworks' first major deliverable. We'll have subsequent, the draft conceptual design report is the first major deliverable, and we'll have subsequent design documents, the 60, 90, and 100% phase to bring to WRF-CAC and to council as well. So the concept design report is really doing a couple of main things for this component of the WRF program. One is to look at the different alignments and different ways that we can run pipes between the existing facility and the new site. The other thing that's critical is looking at the pumping and the orientation and the number of lift stations that we potentially use in order to convey that wastewater from the existing site up to the new site. And then the third thing is really to identify exactly where those pump stations would be located. So we have with us tonight several engineers from Waterworks engineers, and Mike Fisher is going to be giving a presentation that's going to go over these different topics. So I'll pass it to Mike.
Thank you, Eric. Thank you, members, for the opportunity to present. We've been working on this project for approximately 12 months, and through that time frame, we've developed a lot of alternatives, a wide range of alternatives, and the reason for that was to make sure that we've taken into account the various constraints, both cost and non-cost, related to the potential options for the pipeline alignment as well as the pumping options. And we wanted to bring this to you at this phase so that we make sure any comments, concerns, questions that you have from the preliminary assessment get properly depicted in the final version of the concept design report. And that was the reason for, rather than bringing the concept design report first, bring a preliminary findings assessment and then be able to have some interaction with individuals regarding the results. We're going to hit on the design flows that were used. We're going to hit on the route study for the pipeline alternatives, as well as the the pump station alternatives throughout the presentation. And it's subsequent to that, we'll look at what the preferred alternative as we see it now makes the kind of taking into account all those comparable constraints and cost related items. And then we look at what the current total project cost is going to be. And so the first item you'll see in the presentation is kind of a 4-panel overview of the entire process. And in the upper left corner, you'll see a representation of the pipeline decision diagram, basically a process by which we looked at working alignments and then fatal flawed certain alignments due to cost and non-cost constraints, and then took those final alignments, which happened to be the Weston Embarcadero, and I will go through that, how we got to that point. And we took those 2 final alignments into the pump station analysis. And I'll explain throughout this presentation why we got to that point with various slides. But I wanted to give you this as, we wanted to give you this as an overview of the process so that if we, as we go through the presentation, you want to look back at the kind of the flow chart of decision matrices that we went through, you can jump back to that. But at the top left there, you'll see the working alignments led to, and an analysis of those led to the final alignments were then taken through a process to identify some keyed preferred segments that we had to make sure we addressed, and we resulted in a preferred alternative. Whereas on the pump station side, once we took the Weston Embarcadero alignment, we looked at 2 different alternatives: a single pump station that took all of the flow all the way from the current wastewater facility up to the new wharf location, as well as a dual option. And I'll get into the benefits of why a dual option does provide some benefits. And then on the right-hand side of this flow charts for you to have available to you to refer back to as we go through the presentation is the preferred kind of process mechanical diagram of the preferred alternative on the upper right. And in the bottom there to the right, you'll see the preferred alignment as it stands with us at this point in the process. The way that we went through this process was we first looked at the rough design constraints, and the 2 biggest items were what's the design flow for the pump station, and secondarily looking at total what we'll call pumping hydraulics. And those 2 pieces of design conditions affect the leading alignment alternatives and pump analysis. So we just wanted to make sure it was understood that the city has been going through a really advanced process by developing their One Water master planning process, and we integrated considerably with Carollo during that process to make sure that we were bringing to you a design that matched with their build-out conditions. And so you'll see that the pump station is built with a firm capacity of 8.14 million gallons on an hourly peaking basis, and then the brine line to bring flow back from the wharf in the wet conditions when you may not be able to use the indirect potable reuse facilities. You bring brine back down that line. And what that results in is basically 4 different facility types that we are building or looking at in our alternatives alignment. The key one being the force main that takes water up the hill. Then we've got the brine line that brings the treated water down the hill for ocean discharge. We've got the indirect potable reuse line, which is intended to go to the recharge facilities. And then we also have a communications conduit. So when we were looking at alignment alternatives, we were looking at space available for all of those pipes. One of the things you'll notice is in the sewer force mains, one of the, I talked about 2 major constraints that led to the initial assessment. One was, what is the flow? And that leads into hydraulics. And one of the things we saw was, given the range of flow, that 8.14 million gallons on the previous slide that represented kind of the max hourly pumping conditions that the treatment, system produces. Under that condition, it only happens at a very small amount of time. Most of the time when you're operating this plant, it's under 1 million gallons, and in some instances, it's, at the middle of the night, it's as low as 0.3 million gallons per day. Because of that, we believe that a dual force main option provides the best hydraulic conditions, meaning that we don't want to allow velocities at very low flows in a large diameter single pipeline, that can significantly affect operations. And so when we looked at this, we looked at a dual pumps, a dual force main condition, a 12-inch force main for typical operations, a 16-inch force main for as flows increase, and then at the maximum capacity conditions, you'd run both force mains simultaneously. And that's why we looked at that, the dual force main option, and that's what you'll see as we move forward. The offsite pipeline route study, kind of overview of how we produced this process. We developed working alignments, and our working alignments included not only the ones that had previously been discussed, but we also, you'll see in the next couple of slides, looked at a wider range of alignments, thinking that we might be able to find one that was outside of what had been discussed previously, in making every attempt to identify an option that minimize the non-cost impacts that are going to be associated with this project, as well as trying to stay within the available cost matrix within the project. So what we did is we took those wide range of working alignments, we identified the major criteria and constraints associated with those, and then there were certain alignments that fatal flawed based on those major constraints. And I'm going to walk you through each of those, but I want to kind of give you how the process worked. We then, once certain alignments were fatal flawed, we took the final alignments, which I've said are the Weston Embarcadero alignments, and we took those through a detailed cost assessment and a non-cost considerations assessment. And I've got a table in here in a few slides that you'll see. I can walk you through each of those constraints. We then ended up from that to the preferred alignment alternative. So this figure represents kind of the wide range of alternatives that we looked at for the project. And you'll see basically we have the original west alignment that was discussed, which is along the bike path, east along Atascadero, along the bike path till you get onto Quintana Road, up Quintana Road, until you get, this is one variation from what you may have seen in the past, but instead of crossing with a trenchless construction across Highway 1, we drop all the way down onto South Bay Boulevard and have actually integrated, looked with Caltrans about going under the South Bay Boulevard Bridge so that we don't need to do a high-cost trenchless construction under Highway 1. So that is the west alignment. We then also looked at several alignments on the east side. There was several alignments that tried to minimize the total length of the project as much as we could, and those are what you see here as the purple alignments that are the long horizontal directional drilling alignments, and then as well as an open cut alignment. Basically, these are the shortest paths to get from point A to point B, thinking that if we can figure out a way to get there in the shortest possible alignment, would be the minimized cost. And when we get into the next slide, I'll show you why those don't pan out. We also looked at an east alignment that basically got under Highway 1 at Atascadero and then followed along Main Street up into the Radcliffe neighborhood and then along the Highway 1 right-of-way. And what we found, I guess I'll jump back. We also added one additional alignment, which was the Embarcadero alignment, which basically now, instead of going east out of the treatment plant facility and the eventual offsite lift station, we went west along Embarcadero, crossed Morrow Creek here, along Embarcadero, and then up and basically joined the west alignment just past the traffic circle. That is the longest alignment, but it had some potential at the initial discussion about minimizing some of the impacts on Quintana Road, which I know which we knew was something we wanted to try to identify through the process. So what we found, and this is an overview of kind of all of the alignments, from the right-hand side being the three hills alignments I talked about, those ones that were the shortest distance. To the east alignment, which was the one along Highway 1 on the east side of town, the Embarcadero alignment, and the west alignment. And the key constraints, now these aren't only, these are cost and non-cost key constraints. And basically we looked at each of those to make sure which alignments could be taken to the next phase of analysis, basically a very detailed cost analysis. This process basically identified several of the eastern side alignments that fatal flawed. And the reason we say that is, I'm going to take them one at a time and explain that to you why we fatal flaw those. So when I refer to a long HDD, that's horizontal directional drilling, which is basically a way of inserting a pipeline underneath a high elevation with a drilled hole that is then reamed out and held open, and then you pull the pipes back through it. It's one of the several trenchless technologies that are available for pipeline construction. If you'll remember, when you look at these alignments, we looked at an option because from a hydraulic standpoint, you're at a low point here, or I shouldn't say a low point. You're at a elevation here similar to where the connection at the wharf needs to be, and at an elevation here similar to where the wharf connection needs to be. But the highest point along this alignment is close to 400 feet. And because of that, you'll see that that we knew that the open cut across this high point would have required us to be, 415 feet of total dynamic head, basically the hill we have to pump over, and that would have made this infeasible to very abnormal for a pumping condition. And so remember, we're not pumping raw water or clear water here. We're pumping sewage water, which can significantly be impacted by high head conditions, large flow high head conditions. So we we knew that the hill's open cut alignment would fail from that hydraulic standpoint. So we looked at one that could potentially get you that same distance, but in a way that didn't have such a high head to pump over, high elevation to pump over. But this length of horizontal directional drilling, while it is feasible, you would be the only project in the United States right now that's done a horizontal directional drilling of this length. And add on to that, the depths of your pipeline along the alignment would be close to 220 feet deep. So we were looking to try to find a way to minimize the length of the pipeline, and this one just failed from a constructability standpoint. And that's why we fatal flawed the open cut alignment based on hydraulics, and we fatal flawed the long horizontal directional drilling based on the constructability of those projects. So the shortest alignment is out. From the standpoint of the east alignment, there were several conditions along the alignment that impacted our ability to take that alignment to further assessment. And the first one I'm going to talk about a little is the hydraulics. On a first blush, this alignment appears to be less impactful, but at this point in the alignment, as you're all very familiar, I'm sure, with as you're driving north/west on Highway 1, you've got a large embankment there, and getting over the top of that embankment actually does, with an open cut construction, requires you to be across a hill that is 210 feet high, whereas the lowest point, the highest point on either the Embarcadero or west alignment is 150 feet. So that extra 60 feet of hydraulics that you have to get over minimizes the ability and eliminates the ability for you to get over that hump. So we looked at, okay, what about small sections of horizontal directional drilling on the east alignments? Basically getting through this mountain's hillside by going under it. And what you find is that to do that, you significantly impact the stability or potentially impact the stability of this face. Basically, if you're directional drilling in a cut face of a hillside, you create the potential for creating slides. And so you'd be in a situation where you'd have to do a large offset off of the cut next to the freeway, and it results in a very costly and long HDD for just this alignment. Now you add into that, along this east alignment, the scheduling and environmental concerns. These particular crossings here, these creek crossings, would require significant environmental permitting to make the cross with open cut. We could go to an HDD, which would eliminate being inside of the waterway, but now you've added effectively 4 HDD crossings. One to get through this hillside, which we talked about, who had the potential to impacting the slope there. Another one to get across this drainage crossing here, and then a third and a fourth to get across the 2 drainages along the Highway 1 alignment. So given those various conditions, we were put in a position to have to fatal flaw the east alignment. So you will see a discussion of an east and west alternative, and the reason I want to bring that up real quickly is when we first looked at the east alignment along Main Street here, we found another concern, and that is, as you're well aware, there's the bridge on Main Street that crosses Morrow Creek. That's on piles. So the ability to cross that with another horizontal directional drill, in other words, go past the edges of the of the piles that currently hold up the infrastructure on either end. We're in a little bit of soft soils through there, so a lot of your infrastructure in that area requires deep foundations, basically to get down to solid ground to hold the bridge in place. Those piles are so close to the right-of-way that if you were to try to drill past them, you could impact their stability. So this part of the east alignment was fatal flawed on that issue as well. So we looked at the hybrid condition, which would be go on the west, down to Main Street, cross under Main Street, and go along the east alignment. But then we added, when you add in the hydraulics issue related to the inability to open cut this east alignment, and then adding in the environmental scheduling risks associated with HDD, not to mention the potential cost impacts of 4 different HDD crossings of that alignment, we got to a point where the east alignment was fatal flawed. And so I look forward when we get to the question session of going into this further if you have additional assessment, but I'm trying to take you through as much of the detail as I can now so that it starts to maybe peak and identify questions you may have. When you look at the west and Embarcadero, you can see that there's several benefits to the west alignment. There's several benefits to the Embarcadero alignment. All of them we fully recognize have some pretty significant traffic impacts. And so, we have identified in the concept design report our mitigation to those conditions, and we look forward to hearing questions regarding those. But we then took these two, the west and east, west and the Embarcadero alignment, to the next phase, which was a detailed cost estimate of both alternatives, as well as a non-cost assessment of those alternatives. And what really drives the bottom line here is you're looking at about a $13.5 million cost for the force mains and brine line on the west, and about a 15.1 on the Embarcadero side. And the key items there are procurement, property procurement, right-of-way procurement. On the Embarcadero is more complex and more costly. And secondarily, you've got just going back to give you a basis, the west alignment is about 1,700 foot in length. The Embarcadero alignment is 20,000 feet in length. So that additional length costs money. It's more pipe in the ground. I'd like to add into that some of the downsides associated with the Embarcadero alignment as you look at your indirect potable reuse alignments. You've got 2 locations potentially where the indirect potable reuse will be implemented, the west and the east, and you can see that there's an additional cost in either of those cases if you use the Embarcadero alignment versus the west alignment. The impacts on the communication conduit are relatively minimal, but they still are part of the discussion. So with this as our kind of our starting point, we at the initial blush, we knew the west alignment was going to be a potential, a likely alternative. So we took the west and parts of the Embarcadero when we did the pump station analysis into the next phase, which was analyzing the pump stations and what are the hydraulic conditions that impact the size of the pump station, and then the layout of the pump station, a single versus dual pump station. So just a reminder real quick, I wanted to make everybody aware of on the existing system. I'm sure you're all very familiar with this. This is the treatment plant, which is, on Atascadero. Lift station 1 pumps directly to or is pumped through the system to the treatment plant. Lift station 2, which is along the Embarcadero, pumps directly to the treatment plant. And lift station 3, which is effectively at the corner of Quintana and South Bay, is pumps up the hill and then down the Quintana gravity line to the plant. So the single pump station alternative was take all of the flows at the plant, pump them up the hill. That was effectively the alternative. That's very similar to what you've seen on previous assessments. It was the single wharf lift station alternative. Some of the things we ran into with this alternative, the variation in pumping conditions, basically under almost 97% of the time, you're pumping between 0.3 and 2 MGD of flow. So basically 97% of the time your treatment plant's running in a under 2 MGD condition. When you get into those rain events, you start to go above that. In the end, that 8.14 million gallon design flow is really only in high flow, high rain conditions. So that's effectively 0.1% of your time. Basically, 8 hours of the year, you'd be flowing 8.14 million gallons. However, because of that, you create a pumping condition for your pump station that is a very wide array of operating conditions. And so you'll see when we talk about the pump station that completes that need, has a lot of infrastructure that only gets used for a very short period of time. So I'll talk about that in a little bit more detail here in a moment. So what we looked at was, what if we only took basically the north side of town through a new lift station, and then tried to capitalize or maximize the use of existing infrastructure and create a second pump station where lift station 2 pump to a second pump station that's outside of the inundation zone, the storm and inundation zone along the beachfront, and also which also allowed us to then take and also allowed us to do lift station 3 directly into the force main. If we select the west alignment, lift station 3 can pump directly into the west or the Embarcadero alignment. Pump station 3 can go directly into that force main so that you don't have to double pump. So this dual option, we took both the single and the dual to the next phase of assessment and started looking at the size that each of these would be. So basically, this is lift station 1. You're looking at a 6 pump condition, a 6 large pump, and I'll get into the horsepowers of these in a moment just to give you a feel for how big they are. But 6 wet weather pumps and 2 dry weather pumps. That's a significant amount of infrastructure. It also requires a much bigger wet well if you do it in that area, and that's why you'll see a 31-foot deep wet well, and then just for approximation, this is about 70 feet long by 30 foot wide. That is the structure. You can also see that the footprint of the structure is significantly more, 130 foot by 80 foot. So that represents kind of the size of the station if it was a single station. The dual station options have a much smaller footprint. The depth at the treatment plant would still be deep because that's driven by your existing gravity lines that are in place now. So you still have to have it relatively similar depth. But one thing that's key to consider between the two is the single lift station will require almost 60 some type of either drilled displacement column or rock stone columns to hold that station up. You've got soft materials in that area, so we'd have to go down another 30 feet worth of foundation preparation to put that in place, which you're probably very familiar with. A lot of your structures that are in that area have to do that in any case. But you can see that having 60 of those to install versus only 9 of them to install for a smaller 10 by 10 wet well at the single lift station, the dual lift station option at pump station. We referred to them as PSA and PSB when we did a dual station. So PSA would be at the same location as the single station. PSB would be, I'll get into the location of that, but basically at the corner of Quintana and Main. So I'll take you through that in a moment. But that is a change you probably haven't seen on previous assessments of doing a single station versus a dual station. Just to remind everyone, if we do, the architectural layout of this will be very similar to what you're used to seeing on your stations. This is a view of lift station 3 at the corner of South Bay and Quintana. This is a look into the parking lot where lift station 2 is, just down the hill from the Veterans Hall. This layout of what the building looked like is very similar to what we can do when we do the dual pump station option. It kind of reduces the visual impact. If we do this larger building, the infrastructure impacts of the single station will be more significant. But generally, the 2-station option will look very similar and operate very similar to what your staff is already utilizing. So to kind of summarize those dual options, the single station, it has a much larger footprint. It basically has 2 60 horsepower pumps that are running for the majority of the time. When you get into wet weather, you basically, to meet the high pumping head requirements, combined with all of your flow going to that location, requires 6 250 horsepower pumps to make that work. When you look at a dual option, 3 60 horsepower pumps at PSA, which is the same as the single station, and basically 3 250 horsepower pumps at the second station, you can see you just reduced that down. Three entire 250 horsepower pumps are eliminated from the need if you go with the dual pump station option. So that was one of the benefits of the dual option. Under 99.9% of the time of flows, you'll have 5 to potentially 6 of your 250 horsepower pumps not operating. They're there for wet weather and wet weather only. It's a lot of investment in infrastructure that gets very little use, but yet still requires the same level of maintenance that you would have on the smaller pumps. Under the dual pump station option, this is a typical operation. Both stations are running all the time. It's very similar to your existing stations. So from an operation standpoint for staff, it's very similar to what they're operating now. There's a second portion of this, the benefits of collecting a portion of the system by gravity with several of the pump station locations, or the pump station B location that was selected, allows you to collect portions of the gravity gravity system directly into that pump station, so you're not having to take it all the way to the single pump station location. So I'll get into that a little bit here. So the pump station A configuration and location, this applies to if we would have looked at a single station also. But we labeled it as this, single pump station versus the pump station A option. So there were 3 potential sites for that. There was a reuse we wanted to look at again of the existing pump station, trying to utilize existing infrastructure that you have. How could you, implement that existing existing infrastructure, influent pump station that's at the treatment plant, reuse that as the final pump station for the facility. There was some downsides to that, kind of how it impacted the future use of that property. The construction and phasing of utilizing that existing infrastructure was very difficult. And then there's some other items there that basically identified this as a non-preferred option. We then looked at the 2 sites that were presented for us to analyze, basically one on the north side of Atascadero and one on the south side of Atascadero, basically in the place of an existing Rex building that's there now. And what we found was potentially a reduction in permit requirements for the Pump Station 3 site, which was basically already on your property, already being utilized for a utility infrastructure, versus if you go to the north side of Atascadero, that's a much more visually impacting facility. Basically, as you're well aware of the way in which Atascadero looks on that north side, just south of the high school. So you can see here that was those reasons are identified here for selecting the existing infrastructure site, the existing water facility site as where we would recommend putting pump station A or the single pump station. When we look at the pump station B configuration, we looked at several locations, and the locations of these are based on hydraulics. To maximize the benefits of a dual pump station and minimize the number of the amount of pumping infrastructure that you need, we looked basically at elevations that were very similar to what produced that. And those elevations are basically around the intersection of Quintana and Main Street. These 2 are slightly farther south up Quintana. And we found that both of those were not as good from an elevation standpoint. They required property procurement. And in one case, on this side, you get very, very close to the drainage that runs behind those facilities. So the 2 W1A and W1B that are farther up Quintana were eliminated, and we identified Pump Station B as the existing city parcel that's at the corner of Main Street and the Highway 1 on-ramp. And that's an existing parcel that the city owns. There are lots of items we could do to create a good visual condition for that site, but it does present a location for the pump station that would benefit the operations of the system. So we then did a cost analysis, and on first blush, how can a single station be that much more expensive than a dual pump station? That was something that we even looked at several times to make sure we weren't missing something. But the reality is that depth of that structure, the single large station at the location of the current plant, that amount of concrete, that depth, that foundation improvements, when you add all of those up, you get a significant, more costly construction project for the single station, as I showed in the previous slide with the size of that facility. The dual station, because there's a smaller wet well infrastructure, less number of pumps, it results in a less costly construction layout for that dual station option. Also included here, just to give you one of the things we wanted to make sure we looked at was operational costs. You're now going to operate 2 pump stations instead of 1. So operationally, how does that work out? From an O&M and replacement funding standpoint, on a 20-year net present worth, you actually will spend a more significant amount of potential funding for the single stations versus the dual. And you can see that here in the total 20-year net present worth costing of the 2 alternatives. So as an overview of kind of what we're bringing to you as our preferred or recommended project is the dual pump station option with pump station A at the Site 3, which is on the location of the existing Rex building. Pump station B at the intersection of the Main Street and the Highway 1 on-ramp. And the west alignment, which takes you down the bike path, then along Quintana Road, and to South Bay, under South Bay, and to the WRF facility. And the layout of the cost of those facilities is shown here. The pump station and force main and brine are identified here, the $21.9 million. We've included these other 3 items. The communications conduit cost is well defined at this point. There's still the option of both the west and east IPR alignments, so that'll get further refined during your assessment process of the feasibility of those 2 different sites. But we've costed out what those are likely to be, so you'll have that as one of your pieces of information in that decision making. So I appreciate the opportunity to present and look forward to hearing questions and comments.
Thank you. Let's see. You want to start with? You're right. Okay. So let's hear from the public first, so we can make sure we can address any of their comments. Thank you, Mike. I'll now open it up for public comment. Anybody in the audience that would like to comment, please come forward, state your name, and we'd like to hear from you.
Thank you. Good afternoon. Happy holidays, everybody. Smiling faces. I'm Carol Truesdale. I've been here since 1995. My question is this. If you're putting a brand new lift station outside of Limos, where did it show up on the EIR report? And then we're going to be spending another $21+ million. I mean, the citizens right now are having difficulty digesting the $41 surcharge. I don't think this is a good idea. Thank you.
Thank you, Carol. We will address that afterwards. These costs are included, I believe. But welcome.
Hi, Marla Jo Sadowski. I'd like the consultant to describe for the people here and at home the difference between cost and non-cost, assessing that. So I don't believe that most people really understand what he's talking about there. So if you could do that, that'd be helpful. Also, I'm not a fan of this project, and that I'm a climate reality project leader, and as such, I feel it's I can't sit here and listen to this without asking for an inventory a greenhouse gas inventory from the existing plant and the greenhouse gas inventory for all of these options that we're being given here. We need an inventory before we assess what we're doing. If we're interested in doing what the state of California is interested in doing, which is reducing our greenhouse emissions within the next 20 to 30 years, it's projects like these that need to be looked at right now. This project is going to be, if it gets built, operating for the next 30 to 40 years. What is that greenhouse gas inventory looking like? And I'd like to also point some of you perhaps to the International Ocean Acidification Alliance. If you could use your search engines to look that up. And you'll see that the state of California in 2016 was a founding member of that international organization. And this state is very determined and interested and determined to reduce the effects from greenhouse gases that are causing the harm to the ocean. Ocean acidification goes on to hypoxia, which is non-oxygen state in that biosphere. You may not be interested in this. You may think you're interested in global reality with climate, but I'll tell you who is interested for sure, whether they know it or not, are the infants being born today, the children. My grandson, who's 11 years old, 15-year-olds that are going to be 75 in 2078, they care. And I would like every adult in this room to educate yourself.
Thank you. Welcome, sir.
Name's Larry Truesdale. I live here in Morro Bay, North Morro Bay. There is something that seems like minutia at one sense, but I still can't wrap my mind around it, and that is the piping. My understanding is that sewage-containing pipes and potentially potable water pipes have to be separated by a significant distance. I believe 16-inch pipe with 5 feet on either side in a trench. You can't put fresh water in that, and then you have to have the others. There's multiple pipes in this one little green line. Does it all really fit? It's just not quite clear because you have, well, I'll just let you, please explain those details because it almost looks like you have to have east and west both, one for fresh and one for sewage. It's basically law. Okay, that's like that.
Thank you, Larry. Anyone else for public comment? Welcome.
Good afternoon. My name is John Weiss. I'm a business owner and resident of Morro Bay. And one of the, I have any aspects of the project, but the one I'd like to draw on right now is the route of the piping, which is going to, as I understand it, go on Quintana Road. I have great concern because of the business community, not just myself, but Albertsons and others who will be disrupted. And I can tell you from personal experience, having a location in San Luis Obispo, when they paved Madonna Road, which is a 4-lane road, 2 lanes in each direction, so at no time did they have any direction closed. When they were working on one side, they had 1 lane and 1 lane. My business was off 50% during that time. It's a significant amount of business for a small retailer located on Madonna and Los Osos Valley Road. So I can only imagine the route on Quintana Road is going to have a very severe impact, even if, and we only have one lane in each direction, so we know there's going to be directions that will stop. People are creatures of habit. Consumers are creatures of habit. We already compete enough with the internet, so I would ask you to consider going across the highway. It's actually a shorter distance to where you're trying to go. It's also more environmentally sensitive. It doesn't go right by the estuary as the current route does, which is another concern. So I would ask you to look at the route for those two reasons, economic and environmental. Thank you.
Thank you. Anyone else for public comment? All right, seeing none, I'll close public comment and bring it back to our group here. And let's start with discussion. We may need you back up at the stand as the expert to address some of these comments and questions as they relate to this presentation, but we'll start here. Paul, would you like to start on my left here?
Okay. Yeah, Mike, I have a question for you. The 8.14 million gallons a day that you show, I was kind of curious how you came to that amount, and does that exclude Cayucas when they come offline?
So our development of those flows were a direct coordination with Carollo in their development of the One Water Plan. The 8.14 does not include the Cayucas flow. It is the build-out peak wet weather flow in a storm event that was modeled by your master planning company.
If the city were to fix some of its leaky collection system, would that number be reduced? Could it be reduced?
From previous collection systems I've worked in, there is a potential for reduction of I&I. I believe that was addressed pretty significantly within the One Water Plan.
Yeah, and Eric Caceres with the program team. So I guess in previous life, when we were working on the One Water Plan, we did a comprehensive model of the collection system. Again, wanted to get a good sense of exactly what the flows were going to be when Cayucas came off. And again, with the sewer collection systems, really usually it's driven by wet weather. You're getting your peak flows during wet weather. We identified through some advanced flow monitoring work that was done by VNA areas within the city that were prone to more I&I, and we identified and put money in the CIP to fix some of those things, to replace pipelines, to replace manholes on a consistent basis in order to reduce the impacts of I&I. The problem is that's a long process, and we're designing a treatment plant now that needs to be able to handle those peak flows. And unfortunately, they're not really being driven by growth. Those peak wet weather flows that we see now are what we're going to see in the future. So there is no, we're designing for something less and seeing something less and seeing something more in the future. So we're in a position where we need to design the facility to operate and handle the peak flows that we've modeled to date. Now, in the long term, as those projects get done and I&I is reduced, your pumping energy and that you would be needed would be reduced, but you would have to put in the capacity to handle that full 8.14 MGD now.
This idea of the dual lift stations, when did you come up with that concept? I mean, you've been working on this since November of last year.
It was I would say July of this year is when it first jumped to the top as a potential, like that there was some feasibility to it, and it made sense from a pumping and cost standpoint, and we've then further refined it throughout this process.
Well, as Mrs. Truesdale brought up, why wasn't this shown in the EIR? The EIR wasn't certified until September. So you knew about this as the EIR came before us in the Planning Commission and the City Council. It should have been in there. In fact, all the discussions of all your alternative pipelines should have been in the EIR, and they weren't. This is the first time we've seen all this.
So to answer the question on the dual pump stations, the timing of when the dual pump station option, kind of as Mike mentioned, rose to the top, was after we had kind of finalized the EIR. Changes like this in projects happen. And again, it wasn't included in the EIR. We're doing some additional environmental analysis to determine if if there are any additional significant unavoidable impacts that are identified by the secondary pump station. If there aren't, we don't necessarily anticipate that there are going to be, then we would just have to publish an addendum to the EIR. So if there were significant impacts that were identified, then we may have to do a supplemental environmental document as a mitigated negative declaration or an EIR for that specific part of the project. We don't anticipate that, but from a timing standpoint, again, this is it's a concept that's been out there for a while, but again, it was really brought forth as a viable concept as we were finalizing the EIR.
In your matrix where you kind of compared your two different alignments, you had cost versus non-cost, as Marlo Jo brought up, but also one of the things, criteria that wasn't included is what Mr. Weiss brought up, is what the impacts it costs to businesses, which is a big minus in that matrix to the Quintana alignment. I mean, it's going to have an effect. For instance, Highway 1 in Quintana, Main Street is a choke point in the town. Back in 95, when it flooded out from that storm, that north part of town was isolated from the south part of town. That's the only way through there. When they paved that street a few years ago, once you got in it, you're stuck. There's no detour around that area. So it seems to me that is a heavy consideration of where you may want to place your alignment based upon what that might do to traffic and businesses. And the other thing is traffic control is very expensive in your contract. And on top of that, the pavement replacement is very expensive in your contract. And then you have all this displaced material from putting those pipes in the ground. Because you federalize this project, you have to have a designated area to take that spoils. Has all that been considered in doing this alignment down Quintana Road?
The short answer is yes. I can take them individually. I forgot to write down each one individually, but the spoils we have looked at specifically. It's listed in when we get to the point that, again, with the idea of bringing you the initial results and making sure we cover these types of questions, the cost of the pavement, the cost of the spoils, the cost of the traffic impacts are identified individually in a cost estimate that's included in a detailed cost estimate for each of the alternatives. And when we bring the concept design report in its totality with these issues addressed, you will see in there an entire appendix that's detailed on individual line item cost estimates. And those three items are on there specifically. The one that I will comment on, in addition, we have traffic impacts up there. And one of the things you brought up was financial impacts to the non-agency related community businesses. We have included traffic impacts. We have included the cost of traffic impacts. We have developed a mitigation process by which none of those businesses would be I won't say negatively impact. I will say all of those businesses will be able to remain open and accessible throughout the project. But the physical cost, and to go to the question about cost to non-cost related items within our approach of assessment, cost would be any items that were specifically borne by the agency. So in this case, by the City of Morro Bay, those costs that are borne by you through the bid process, through property procurement, through permitting activities. But the non-cost items would be items that do not result in a direct cost to the city. Now, I recognize that business reduction is a direct cost reduction to the city from a sales tax standpoint. We have not quantified that to date, and that is something we can look into as an assessment item to add to the report.
I would just add briefly, as Mike started off with, there's a number of different constraints when we're talking about running, in this case, several larger diameter pipelines across essentially the whole city. And when you look at some of these things, and the reason why some of these alignments were fatal flawed, or some were scored differently than others, we do have a tough job in terms of balancing things like the business impacts, the cultural and archaeological resources that we know can be a significant issues for the projects, and so and then other other things like just the constructability and the technical feasibility of operating on that east side. Mike and his team and staff did a good job of looking at all those things and considering everything. The west alignment really is the best option, and it will be the focus of the rest of the design effort is to figure out the ways to mitigate the impacts to those businesses. And as Mike said, we can't completely eliminate those impacts, but that will be our focus moving forward on the design of this.
You also touched on the cultural resources, and as I recall, the west alignment is the one that hit them, that it caused the Class 1 impacts. Where are we in studying or doing the Section 106 studies right now?
I can say that
started that yet?
What I can say is that where we are in the process is as you may remember, right around the time when we were presented the final EIR, we got comments on the draft EIR about the alignment and specifically on the bike path through Lila Kaiser Park. So in working with Mr. Collins from the Northern Chumash Tribe, we modified our alignment slightly in order to stay out of the Lila Kaiser Park area. So that's the alignment. You can kind of see it here. The darker green line shows the original alignment. The lighter green line that goes in Atascadero Road and then goes south in the Caltrans right-of-way in the on-ramp is the revised alignment. And so we responded to Mr. Collins' concerns and changed the project slightly.
But how do we know that there's not cultural resources underneath Highway 1? I mean, some of the sites go back 9,000 years.
No, I understand that.
I mean, you're not out of the woods yet with that alignment.
Absolutely, yeah.
We do have one benefit with that alignment, that where we would put that alignment will not require as much excavation into existing ground surface because of where we'll be placing it along the edge of the Caltrans right-of-way. So it'll be more in a fill slope than in a excavated slope. That benefits from trying to minimize, that was the intent of trying to take it along that alignment, was minimize the amount of excavation in those potential areas. And that would be one benefit to being in that versus, if you take the Embarcadero alignment as an example, you're going to cross right through one of the sites.
Do you have a typical section that shows you how these pipes are going to lay out inside this trench?
Yes, we do. We tried to be prepared for some of these. So this does not show as. So basically, you've got the brine pipe. So this is basically an 18-foot wide impacted area to the full limits of existing infrastructure. This actually goes to two questions that were brought up. And I'm sorry, I forgot your name, sir, but you asked the question about required offset from existing potable water features and the requirement that a sewage force main be a certain distance or a sewage line be a certain distance away from a water line. So this covers two items. The initial trench that would be constructed would be about 8-foot diameter width, and would have all three, both the brine line, the two force mains, in it. And that was would get constructed in one excavation. Separately, as you do a lead trench that would be construct the three pipelines related to the brine and force main, you would then come behind it with a secondary trench for the indirect potable reuse line. That would be at a higher elevation and offset from the sewer lines to meet Division of Drinking Water separation requirements. And we've been in contact with Division of Drinking Water to talk through this trench section, and we're still taking input from them. And we've already even modified this trench section once based on their input. So this is the kind of impact area from this edge of the IPR line trench to the far edge of the three-pipe layout is about a 12-foot impact. Now, we fully recognize that that's 12 foot of construction. That does not take into account the extents of traffic, materials movement, equipment movement, installation conditions. So, the width of that area is more than just that 12 feet. But this allows us to lay it out in a constructible manner.
How much cover are you going to have over the pipes?
It will depend along the alignment. In some cases, we may go as shallow as 30 inches if we need to get over an existing utility, and we'll try to minimize it in the majority of the alignment. But there are places, our current maximum depth, based on what we know about existing utilities, we're very comfortable with the plan view location of existing utilities. We are going through a process of potholing certain crossings to confirm what depth we would have to be at along the entire alignment, but we anticipate being a worst case of 7 foot deep on typical construction. So somewhere between 30 inch and 7 foot deep.
7 feet of cover or 7 feet to the bottom of the trench?
It'll be probably closer to 10 feet to the bottom of the trench and
Okay.
7 feet of cover, yeah.
And that includes even going in the streets in Quintana Road? Will you be at that depth?
There's sections of Quintana we actually think will be at the 30 inch cover, not the 7 feet. But there are, again, not knowing the depths of the crossings at this point, we feel very comfortable that we'll be no deeper than the 10 feet in Quintana, but we don't know how many places will be 30 inches of cover.
Now, getting back to the cultural resources, is there anything that could be found during construction or during the studies that may change your alignment? Like a buried body?
Well, I can tell you during construction, we will have to meet all of the mitigation requirements laid out in the EIR, and those mitigation requirements include the potential of an archaeological or cultural resource. So yes, we would have, through like any pipeline project that gets in any proximity to a potential cultural or archaeological site, you would have to stop and meet the mitigation requirements, whether it's a categorically exempt project or whether it's a project completed under an environmental impact report. You have to meet your mitigation requirements. So if we hit a body, we would have to stop the project.
The Section 106 process, which I've done myself, takes a very, very long time. Has that process started, and when do we expect completion of Section 106, National Historic Preservation Act?
We haven't started the Section 106 process. So in the staff report, we identified kind of a timeline for the different things that need to be done. As Mike mentioned, we're obviously going to be moving the design forward as quickly as we can. But there's a couple things that we need to get finalized before we can do that and start some of these things. And really, it's the things that we're talking here tonight about. So we need to have the pipeline alignment finalized. To a certain extent, we've presented the pipeline alignment before. We're presenting our recommendation here tonight, and the plan would be to go to council in January with a very similar presentation to this one and ask for their direction in terms of the pipeline alignment. So once we can get the pipeline alignment finalized, and then the second piece would be the concurrence with our recommendation to go with the dual pump station option. So we get those two pieces of information. And the third would be getting some confirmation on the locations where we would like to put the lift stations. That will then allow us to expedite the design and continue on with the permitting process, because we actually have an alignment. Right now, the alignments are pretty different, and so or the potential alignments that are out there. So we need to get over or through this process so that we can start those things. So that's really the start of that tonight.
All right, thank you. That's all I have.
Hopefully, I can go through these fairly quick. The first one is on the Embarcadero and running that alignment. To open cut down the Embarcadero, are you going to encounter water where you're going to have to dewater those trenches all the time at that location?
So, yes, we will hit a more significant dewatering impact associated with the Embarcadero alignment than we would have on the west alignment. And
I mean, that kind of scared me when that was one of the ones you were proposing.
Yep.
As far as this goes. So you are assuming you're going to encounter water as part of this?
Yes, and it's included in the detailed cost estimate.
Oh, okay. The second question, and this gets more into the pumps themselves, with the dual force main system, I'm trying to get my head around how it works and everything. Is it fair to say PSA would cover mostly North Morro Bay's effluent and PSB covering the downtown area?
Correct.
Oh, okay, and then the one down at South Bay Boulevard will remain the same and just merely tie into the force main that's coming down Quintana?
Yes.
Oh, okay.
Yes.
Oh, okay. So that basically, I guess the question I have, and I don't have a big problem with dual force main dual pumping stations as opposed, because we already have, what, about 3 or 4 in town already. Does this, other than the one at Atascadero Road with PSA, would PSB remove any existing lift stations out of the mix once it goes in? Or does it gravity from that location over to the over to the wastewater plant?
Yeah, so this particular slide, this is, on you've seen in your presentation the details of the multi-pump station option. This, I wanted to kind of remind you of that and then bring it up in a visual. Basically, everything from this treatment plant north would go to PSA.
Right, okay, I got it.
Everything in the pink area effectively goes to PSA also.
Okay.
This section here, gravity flows to lift station 2.
Okay.
And then we would pump from lift station 2 into the west alignment.
Oh.
And it would go to PSB.
When you say lift station 2, that's a PSB, or is that
sorry,
an
lift station, your existing lift station 2.
Oh, it's an existing.
So that, again, the benefit being not pumping it over to PSA, then from
okay,
PSA
so
to
lift station 2 would still be active and feed directly into the
force
new
main,
force
the
main.
new force
Okay,
main. And then
gotcha.
this section, then highlighted in blue, which now flows all the way along Main Street onto Atascadero and to the treatment plant, it would be intercepted and taken directly into PSB.
Okay, so it does gravity all the way from
This
Main
section
and
does.
Quintana over to the over to the plant.
Correct.
Okay.
Correct. And your last question was about lift station 3.
Right, and that's the
that's
stuff on
obviously
that
it would go
side,
right
yeah.
in.
Oh, okay. And then the let's see. When we had let the original contract to the Waterworks Engineering, as I remember, the IPR lines were not part of the original contract. Has that been made part of the contract now?
Yeah, that's correct. I think.
I mean, I don't want to build this twice. If we're going to go through this, I assume it's going to go in at the same time as the other.
Yeah, I think some of the initial, there's some initial hesitation before it was looked at a high level of detail about the ability, depending on what the alignment was, to fit all those pipes together. And so once we started to think about once we started to understand that it was probably feasible to include all of those pipelines together, that's when we made the decision to move that into this
so they're
project.
on board to prepare the IPR.
Yes, that will be their contract will be modified to include the additional effort for the design of that pipeline.
And then the last question, if you could bring up the one that shows all the different alternative routes. I think it was the last in this thing. I noticed on the west, as you come down, just before you reach the Cookie Crock shopping center down there, I was wondering if there's an ability to horizontal directionally drill over to the east side. And I realize you brought up a few concerns further east where you have that larger embankment cut on Highway 1 down near South Bay Boulevard. But it also looked like if you sat there, come down further down the road there. If you just
This way?
Yeah, keep coming down, keep coming, right about there. If you just went straight across the hill up to that corner up there, it seems like you'd be far enough away from that open cut that you wouldn't have the kind of issues you were bringing up. In my own mind, when I first looked at this, it kind of made sense to me. It's going to be a mess on Quintana. I agree with Paul wholeheartedly. And what I'm trying to do is, it would still impact down near Limos and Pete's Tire and some of those places down there. But I know why you don't want to be on the east side, up around the bridge where Little Morrow Creek comes through and all of that. It just made sense at some point to jump the road and not go all the way down Quintana, because you'd be really limiting the amount of stores that would be affected if you could get over to the east after you get just beyond that subdivision, right in there. Yeah, somewhere down in there, cross over, or at least take a look at it and try to get an idea to quantify cost on that. You know, I can't tell you how much. I don't know what it costs to do horizontal directional drilling. I'm sure it's very expensive, but it's also very expensive, like Paul brought up, to take down take down Quintana Road and try to keep the traffic control moving through there. That I've seen that in my own life, and that can be a lot of issue. That's my only question, so I'll go ahead and pass her down. Yeah.
I guess this is a question for Rob. Do you know? This is a question maybe Rob can answer. Or when would the traffic plan, more detailed traffic plans be developed for this project, and particularly in regards to Quintana? I mean, are we envisioning putting our pipes down the middle of the road, one lane? Would it be I think there's this vision that the whole thing's going to be torn up all at once, and we wouldn't have access to any of the facilities that we all rely on. Is night construction in the mix?
Night construction is in the mix. One thing, as Mike pointed out, we have good information on horizontal location. We need better information on the depth of the crossings to finally refine that, so we need to get out there and do some potholing on there. There's, other than water utilities, there's also high-pressure gas main that goes up Quintana that we need to avoid. From what I recall, it's near the middle section of the road is where the clearest spot is. We anticipate night work with limited backfill or plating to get the street back open again is some of the things that we've thought about for this construction activity. But we need to advance the design a little bit further before we can develop those traffic control plans.
I guess, and then it would be in increments. Do we have an idea? I remember one time we talked about this, but what the length that we would be constructing at any one given time, rather than envisioning it that the whole Quintana's torn up all at once. What would be the segments that we would potentially be working on?
So we'd do it in a phased approach, that we would make the crossing of the roundabout one phase, and then from the roundabout approximately 1,500 to 2,000 feet down the alignment. So for rough estimates, halfway down Quintana would be impacted, and then the other half of Quintana. If you look at Quintana south to north from the roundabout till you hit Main Street, we'd do it in two phases. And not the entire road within a given phase would be impacted, but you need the space within there, given the type of pipe we're planning to use. You'd need to phase that such that half of it is being opened up and constructed within. Then you'd fill that back up and use that space to do the next half of that 2,000 feet. And so that's why about 2,500 feet, or 1,500 to 2,500, depending on how many different phases we want to do it in. And to Rob's point, that's that phasing details, especially the traffic control plan and the maintenance of services. Those types of things would be done at the 60% plan, the next deliverable for the preferred alignment. So 1,500 feet at a time, probably two phases for Quintana Road.
Okay. Would one of the roadway lanes be available for traffic?
As of right now, we are anticipating maintaining one-way access along
One-way
Quintana Road.
access, okay. One of the things I was thinking about, too, in regards to something that Marla Jo brought out in terms of comparing greenhouse inventory, comparison with the different options, and it just intuitively, it seems that the dual system would be less greenhouse emissions as opposed to the larger system. I'm wondering if you were to compare those two, if that would pencil out.
Yes, so we haven't done a detailed greenhouse gas assessment for the two alternatives. I will say this: the operating efficiency points for the pump stations in the dual option, we are in a better operating point for the pumps in the dual option than we are in the single.
Yeah, it just seemed that way. One thing that, in regards to the west alignment, I know that it was one of my comments in the environmental impact report, and I know the cultural resource specialists that worked on this project recommended to the city that to not take that left turn at the creek, but to go straight as we're doing now, and then soon after that, with the behest of Native American community speaking up, I think that's probably the best way to go. I do know that a couple of other archaeological studies have been conducted in, say, the Lila Kaiser Park area. I'm thinking about one project in particular that was done by John Parker and had to do, I think, for some light standards. Were you here, Rob, when he was out there doing auger borings?
I think that predates me.
Okay. As he continued to the east towards the highway, when he was in the heart of Lila Kaiser and around the creek embankment, further to the heading towards the ocean, he was in a much richer component of the site. But as he headed towards the highway in his auger samples, his most, let's just call it easterly, contained very little material. It was gravel with a few pieces of shell. Very little information about that area. I do know that another person did some work in the right-of-way, I think his name Bob Gibson. He did some work along the highway right-of-way along that west alignment and came up with negative results. We all know that area is very sensitive, and there's always the potential that you will find something, and that whatever you do in terms of moving forward, that you'll have a mitigation plan developed in the event something is found during construction. And no matter where we go, if we were to go to the east or if we were to go to the west or whatever alignment, we always run into that potential that we're going to find something. So,
Thank you.
anyway, I think that's it.
Thank you, Valerie. I want to hold off mine till the end because I have more comments on the way this is written and something that may help the public. If Jesse, please go ahead.
I had a couple comments. I was a little curious, going back to the structural for the lift stations. You went from 60 caissons, I'm going to call them, for lack of a better term, to 9. And I'm sorry, yeah. So, presuming these are in a relatively uniform soil material, how does that occur? Why does that occur, I should say?
So the spacing, we've done a preliminary geotechnical analysis of the site. They use Yee and Associates to do that. They've done significant work on the treatment plant site as well as are doing other work across the city and across this project range. They identified a soft sand material at 30 feet deep and then a harder clay material at 60 feet deep. So you're building, they made basically a recommendation that the best way to mitigate a potential for settlement of the structure and in a liquefying condition where the earthquake may result in a liquefied condition and the structure would sink, they recommended basically 30-inch rock caissons, drilled rock caissons on a 10-foot, 6-foot or 10-foot? 6-foot center. And so if you think about the size, what that would result in, if this is 70 foot by 30 foot, you need a caisson every 6 feet along within the entire footprint of the structure. So you've got effectively 12 by 5.
I guess my question is, how does the footprint shrink so dramatically from the single station concept to the dual station concept?
Yep. So the reason for that is when you go with a single station option, we talked extensively with operations about their desires for a single station option and what type of facility they would like to utilize. When you have a single station option, higher flows, bigger pump conditions. And so the design of the station is a trench style self-cleaning wet well, which requires a little deeper structure and a little wider structure to line up the pumps in series such that you can do self-cleaning. I don't how much detail you want me to get into self-cleaning wells, but
just the footprint. The footprint was I just didn't understand.
Yeah. So lining up all eight pumps in a row along the length combined with the size of the trench you need to create the operating environment that makes a self-cleaning trench-style wet well successful, results in a much wider footprint versus this is, like I said, your classic three-pump, smaller, more classic on-off, although this particular station will operate as a VFD as well, so it can modulate flows. It results in a 10 by 10 impact area. That's
I'm not sure I still understand that, but I'll dig a little deeper on my own, I guess. Flows impression.
It really comes down to a dry pit submersible design versus a wet pit submersible design. So I guess one piece of the equation that maybe I didn't explain very well. In a wet pit or what's called a dry pit submersible design, your pumps are at the same, your driving motor facility is at the same elevation as the inlet to the pump, just like you would in a submersible pump. But in this design, you actually have the ability to get at the pumps separately from the motors separately from the pumps. So all of these pumps that are lined up back here, and I can get a 3D rotator if you'd like, they're in a dry environment. So the bottom of this has an entire section that's the pumps in a dry condition so the operators can walk down to them and look at them, versus in this setup, those pumps are wet, the motors are wet, and you pull them up out of the ground to maintain them.
That makes sense.
So, sorry.
No, that got me there. I had an aha moment in the middle there. So, okay, yep. I'm with you. I guess just my next thing is just more of a comment because, I mean, my colleagues have addressed it, but the traffic and the schedule, to me, I mean, I understand the desire to want to go down Quintana and the West Alignment. I understand how that's preferred. I'm really concerned, as everybody else is here, with the traffic and with the scheduling, and undoing what we're, doing it and undoing it every day. It seems counterintuitive to efficiency to me. The horizontal drilling. I'm sorry. That you, Stephen, had discussed about getting across and horizontal drilling across those drainage channels. While it might be more expensive, I mean, I think we have to look bigger and look at the impact of the community as well, impact to our tourist-based economy here. What are we doing to, are we going to do this in the middle of July? Is this going to be, So anyway, those are my comments.
2009, Carollo Engineering was doing an upgrade on the existing site, and I would like to know, at that time, we had a peak of 6+ MGD, peak wet weather. That was with Cayucas. Now, in 2003 and 2004, I worked for the Cayucas Sanitary District and did their flow studies, and the inflow and infiltration rates were about 3 times the average flows, which made it in about 1 million gallons. So if you had 6+ wet weather flow with Cayucas, one would assume that your wet weather flow without Cayucas would be in the range of under 6, and you're running around 8.1. You made a comment. What's your name?
Eric.
Eric?
Yes.
You made a comment regarding correcting regarding inflow and infiltration and how it affects the peak weather flows and the reductions, and it didn't really make a lot of sense to me, because it seems to me that what we're designing for is putting a Band-Aid on a problem that we have. Now, it would appear to me that it would be prudent to address our I&I issue immediately. And one of the areas that we know we have problems with is the 60/40 sewer main line, which is infiltrating and exfiltrating sewage in our drinking water aquifer. I feel that your data, your parameters are skewed toward sprawl and development, because what it looks like to me is we're upsizing the plant to, what did you say, you go average from 0.3 to almost 2 MGD. We're running back in 2009, when they were going to upgrade the plant, they were actually going to reduce the size of the plant these were figures with Cayucas, because they were trying to get it on that one space. It was a bad project because it was actually moving it closer to the creek. I highly suspect of your flow numbers. The other thing that I want to make a comment on with regards to alignment, not that I'm in favor of any of this, is I was environmental monitor at the time when we did a lift station in Cayucas, and we did a horizontal drill underneath the creek. I can't remember the contractor's name. And, there's issues when you talk about environmental issues like fracking out and those kind of things. I understand that. However, I'm not going to repeat what other people are concerned with regards to the effects on open trench and the closing down of our area there. But when I look back and take a step back on this project, the citizens of Morro Bay within the last decade had put in a new headworks at the existing plant. They've had rebuilt the South Bay Boulevard site and installed the force main there. And so all that is going to go away, right? All that is going to be just to waste.
Lift Station 3 will remain in service and is actually well situated at its current pumping capacities. As in that same project you're referring to, they upgraded Lift Station 2 also, and it will be able to be reused.
Okay.
The alignment that they used on Quintana Road for the force main, that actually the fact that they did it provides it's the exact location where the new alignment will go.
Okay.
And so there are actually some benefits to the fact that alignment was created and placed in service.
Have you considered pipe bursting at all? Oh, I did a pipe bursting job over in Cayucas as well. That's a way to avoid a lot of issues with the archaeologicals and everything else.
Yeah, so if you've done a pipe, so you're very familiar with pipe bursting. The way that process works is, right, you can put a single pipe in where a single pipe is.
Right.
We run this. We're in that difficult situation where we want to have 3 pipes in close proximity to one another, whereas pipe bursting may not be as beneficial to that because we got to put 3 pipes in.
And, okay, so that said, the other thing that is regarding, I still haven't got an answer and I've asked this in the EIR, but can you give me an estimate on, let's say, how much energy you anticipate? Let's just say that your preferred option, how much energy increase, usage throughout the year or month is going to be used in the added lift stations. In addition, this is for the citizens. In addition to the added personnel that they're going to use to travel around. See, these are all part of that greenhouse gas inventory that needs to be taken into account.
So within the concept design report, there is an analysis of energy use by facility, and there is a analysis of operational needs for the sites, mostly focused on replacement cost, not as much focused on man-hour changes or person-hour changes. So I would defer to Eric on that particular question. But from an energy use standpoint, we absolutely have that addressed within the
Okay, so you're going to have so we'll have energy uses for lift station, at the plant, energy for the second lift station that you're adding.
As well as replacement costs for those facilities over a 20-year net present worth, absolutely.
Okay, and then the energy costs for pumping all that stuff back down, right?
Correct.
Okay, so those are all part of that greenhouse gas inventory that you guys going to come together in? Because I think that's kind of law right now that you have to address that.
Yeah, and I can get you a more detailed answer when I dig into the EIR. So the EIR considered greenhouse gas emissions for the various components of the project. And then as a separate note, in looking at the energy usage, so in order to come up with the long-term O&M costs that were used in the rate study that was used for the Prop 218 process, we did a detailed analysis working with operations and working with the design engineer on the lift stations and force mains, as well as information provided by the design build team to come up with estimates for energy usage and personnel for not just the conveyance facilities or the wastewater treatment plant, but essentially how the wastewater utility would operate after this program is done and all these facilities are in operation. So we've taken all of that into account in terms of the long-term cost forecasting for the
But
project.
I just want to state that I saw the EIR, and you didn't assess the greenhouse gases. You kind of washed over them. They were not properly assessed.
I'll take a look at that.
Thank you, Richard. Doug?
I'm curious about that pump station 3.
I think you might have to redo it.
Pump station 3, you had a graph there with the blue line around. I understood that to be the area that's going to be served by that pump station 3.
Yes.
And I wasn't really clear.
No, and I'm sorry, I went through that quickly.
Yeah.
So just what this represents is the current system, mostly the southern part of the current system. Lift Station 3 takes gravity flows from this area and pumps them currently up the hill, and they flow by gravity all the way to the plant.
I see.
Okay. The preferred alignment would pump those directly into the force main, so you would no longer pump them up the hill. And secondarily, in the 2 pump station option, this portion in blue of the system that currently operates as a gravity system, basically it takes all this flows by gravity all the way to the treatment plant. In the 2 pump station option, we can intercept those gravity flows and take them directly into pump station B. Whereas if you do a single station, they still have to flow all the way from the south side of town to the center of town and then get pumped all the way back up. So that's why we were identifying the dual pump station option.
So pump station 3, I guess I'm kind of I don't understand. What's the function of it? It's not serving a very big area.
It is not serving a very big area, but the treatment plant being up gradient from it, we still need to leave the lift station 3 in operation.
Sure,
because
no, I understand that.
Okay, sorry.
So the blue area and the yellow area on that map all would go to this, what would be this lift station 2, and then connect to the pipe somewhere along Quintana.
Yeah, so the blue area would actually go directly to the new pump station B. The area in the yellow would continue to gravity feed to lift station 2 and then pump to pump station B.
Okay.
Because if you think of basically the way the system is already piped, there's a high point along this, and I know this one isn't exactly accurate, but it's close. Think of it as a high point along in that area. So the sewer basins were developed so that everything flows by gravity in that direction to lift station 2, whereas this section flows by gravity around into the plant.
Okay. Okay. My other comment is there's so much discussion about the flows and the leakage of the pipes. I mean, I hear this over and over. It'd be nice to have it identified as to exactly how these flows were developed and what percentage of that is leakage or whatever, if it really is such a big deal. I don't know if it is. I'm not sure. It's kind of confusing to me.
I think you asked a good question, which was a follow-up to what Mr. Sadowski was asking about the flow questions. So back in 2007, when the original master plan was completed, there was a wet weather flow figure that was presented. I know once that was identified, there were some issues that were identified with the flow meter at the plant, that it wasn't reading accurately, or it was capping out at a certain flow. And so when the design engineer for that project came on board, Montgomery Watson, they did an updated flow analysis and came up with a higher peak hour flow number. The benefit that we have at this point in time is the peak hour flow number, the 8.14 MGD, was developed not just by looking at what the influent flows have been historically into the plant, but the benefit is that the model was created for the whole collection system. And in tandem with creating that model and giving you the ability to have a more accurate representation of what the flows will be, the city also invested in having a third-party V&A come and do a extended, dry and wet weather flow analysis that was used to calibrate that model. And so I would point you to that report, which is an appendix to the One Water Plan that will give you an idea of all the flow monitoring that was done to come up with that 8.14 MGD. And that'll give you a sense of the difference between, or the relationship between the dry weather, because there was flow monitoring done during dry weather and also flow monitoring done during wet weather. The way that study was done is each individual sub-basin or sub-catchment within the city's collection system was a monitor was put there. And so that study was able to take out the Cayucas component of the flow. So it wasn't measuring flows necessarily just at the headworks of the treatment plant, but it was measuring all the individual sub-basins that come to the treatment plant. So it was, if you want to get a really good sense of what the flows are going to be, that's the way that you would undertake one of those studies.
Well, you got a correction there on the 2009 is when they had those numbers, and that new flow meter was in by then. And also the Cayucas flows are a little bit skewed because they're measured at lift station 5, and then there's an additional infiltration issue once it gets into the city. So, you don't have a clear picture there with regards to the I&I on that.
Noted. Okay, so I just have a couple other comments, and maybe then I'll ask, if anything else hasn't been addressed, I'll ask Eric or Rob. When I look at this, since we are a citizens group, unfortunately, several of our members are engineers and really understand this. But I personally, I'm more in the finance and contracts world. I had a little difficulty reading this report and following it, so I just have some suggestions for you so that when this is presented in the future, perhaps it'll be a little clearer. And then I also have some questions. So my first thing is, when you start with the background in that, you define somewhere what exactly is the WRF conveyance system. Does it include, it has it here in parentheses, I would put right there into the background that second sentence what it is, then in parentheses, all pipelines to connect, like the brine line and all that, and also the recycled. It was a little confusing in that long sentence, so just a point of information. I'm looking for the clarity here. On the second page of the agenda, page 2 of 8, once again, I was confused on the very top where it says the W Waterworks Engineering Design Services, and it includes 6 bullets. And the third bullet says preparation of a concept design report, 30%. What's that mean? 30% done, or 30% of the project, or whatever, complete? And I took it to mean 30% complete. But then the next bullet is preparation of the draft construction documents, including I think it should be plans, specifications, and estimates, right? At 60%, 90%, and 100%. When you have to have the 30% bullet above it, 100% complete to accurately do the 30s or the 60, 90, 100% in the next bullet?
We can, yes, definitely.
Is that correct?
The 30% description under the preliminary, under the concept design report is a representation of 30% design, and then 60,
okay.
90, 100 follow. So we're at 30% design when we submit the concept design report.
Okay.
So
okay.
we can clarify that definitely.
Right.
Yep. I understood.
Confusing. Okay. And then when I was reading further on the bottom of that same page too about the preliminary assessment and the final, the fatal flaws that were eliminated, it says west alignment and east alignment. And then I go here, well, did they read? Then I was confused on the west IPR and east. And again, I'm trying to avoid 15 citizens trying to, regurgitate this and then come up to public comment and ask the same.
Totally understand. A typo
So-
like that's unacceptable for me to let that go through.
Okay,
That was a
okay.
typo that I missed.
Well, I'm not pointing, some of these
no,
are minor.
I want to
but
take
yeah.
credit for that one. That was my mistake, and excuse me.
Okay, because then on the next one, we should have a total on some of these. Some of the charts they do, some of them don't. So if we could put totals on them. The other thing that's confusing, and I don't think it'll show up well in the overhead, is when you get into the non-cost project constraints and the pluses and the minuses. I would put those as numbers. So I started looking at, well, how do I count which one's the best? Or I think I put the numbers, and then you could put a subtotal.
We used to have a 1 through 10 approach, and it got very...
Well, that's a little more subjective, I agree, but you could do +1, -1, 0.
That sounds good. I like that approach.
Something like that. And then when I got to the bottom on the pump station total construction cost summary, and I think they were going with, you were recommending scenario 3, the full-time. But the estimated O&M cost, I assume that's estimated annual O&M costs, right? It's $83,000 versus $70,000, considerably 19% higher. Why is that? Only to save $14,000 on the bottom replacement costs. So I would put a little explanation in there because a lot of what we're looking at is ongoing costs, not just one time.
Understood.
And it's questionable how seems to me that's less costly alternative. Maybe there's other
Understood
reasons.
why it appears that way. We'll update it.
Okay. Some of the attachments should be labeled, obviously, wherever. I recognize this as a draft, but please. And even on some of the attachments, some of the acronyms, maybe a little legend or something there, so not everybody knows. That's why all the some of the questions here. And then the other question is, several of the people have been commenting on the impact of the business, and somebody suggested that could be 50%. I don't know, but based on your experience with some of these other projects that you've said similar, we know there's going to be some hit because there's an inconvenience factor. Is that going to be 50% on any particular business? Could it be 10%? Could it vary? Is that the average, max? Do you know?
I don't think it would be right for me to make an assessment of the businesses that are specific to your city. And I understand, too, that the uses within those businesses and how they are impacted on a weekly, daily, seasonal basis. We don't know those details down to that level at this point, so it's understood. I will say that we've constructed projects of the similar nature, and we have seen situations where impacts have been considerably less than 50%. So I don't want to minimize the importance of that discussion because I know the gentleman who talked about the paving project in San Luis Obispo, that's a real impact that he felt. So I don't want to in any way minimize. I just know that I don't know those numbers for your specific area at this point in time. We have seen less. And obviously, we've seen 50% as well because there's a gentleman who had it happen directly to him.
Well, I know the sales tax is the biggest thing, obviously, and that's 14% of our general fund revenue. So, but we also subscribe the city to the HDL data. Maybe we could, as you further refine those, what happens if you start taking those non-cost items and they are significant? Is that going to change any of this, or could it, or are we talking about, we can move it somewhere else, but the cost is going to be higher? That's my concern.
I think we can influence some of that a little bit by the way we message going out to the community what this project is, the timing of the construction, what time of year that we'll actually build it in, and then what time of days that will be active in the street. So those are things, should the west alignment win out, those are things that we can control through the construction documents and require the contractor to comply with those specific measures.
That would help, obviously. And I guess a final question, when we were, Eric, maybe to you, on the Blue Ribbon Commission, when that idea originally came up about not doing the pipes on both sides of Quintana, is some of this a result of that? Because that, was obviously a very more costly alternative. You recall that?
Yeah, I think that was, I think one of the main reasons, or one of the major reasons why we decided to consolidate was the discussions that we had in the Blue Ribbon Commission, wanting to obviously make the project as affordable as possible and wanting to reduce cost. I think the other piece of it is that, and we've talked about wanting to use the west alignment, or could we use the east alignments? I think for the most part, and as Mike mentioned, we looked at those and we identified some fatal flaws with being on the east side of the highway. And so it's a little bit less of a want and more of a need to be on the west side of the highway for a number of different reasons. As we mentioned, there's archaeological concerns, there's concerns with constructability and risk to the city of undertaking a very complex or a very deep trenchless construction method. We know there's issues with environmental and the creek crossings and all of those things. And so I think those two things together and wanting to keep everything on the west side if we could, and then also the cost savings that we get with doing those two projects together, that was kind of the driver for that. And then, again, identifying the feasibility and development of a trench section, a typical trench section that would work with to accommodate all those pipes and would also meet DDW's requirements.
Okay, thank you. Rob, do you have anything to add based on any of the points brought up by the public or anybody else up here?
I'm just going back and reviewing some of the questions that we had early on. We talked about how we need to do some additional environmental review for the second lift station, whether that's an addendum or a document that gets recirculated. The $20 million in costs that was brought up earlier, that is built into the rates. So the cost of this pipeline and lift station is already in the rates. It's not additional costs. Pipeline separation, does it all fit? We have showed the cross section and it works. We'll still need to do we need to do more work on what the impact is to the businesses and bring that forward.
And then the question Steve posed on the horizontal, cutting it up,
I was just saying more,
Yeah.
doing
FYI.
west.
Another hybrid option.
Another hybrid option. I think we still run into the problem with elevation there and trying to pump.
So I definitely understand why that appears like from this view to look potential. This hill continues to go up, so you're talking about being about 180 feet deep with the center line of that at the midpoint of that HDD, and you start to get into some infeasibility with the types of pipelines. So then you're talking about putting a casing in first, and then that casing.
So you're worried about collapsing the pipe.
Correct.
Gotcha.
Yeah.
That, fair enough.
in layman's
I
terms.
didn't study the topography. It caught my eye when you were going through this.
Understand.
Richard, go ahead.
Yeah, I just want to make a comment. I looked up my data, and the current plant is for a peak dry weather was 2.36, and peak wet weather is 6.64 MGD. That's with Cayucas, and according to the 2017 monitoring report for the existing plant, and I quote, the plant's flow did not even approach, much less surpass any of the design limits during 2017.
What page is that on?
That's a reference that I have on the document.
May I ask one more question, since Rob's going to do a little bit more digging? So the slope stability analysis that was done for the horizontal drilling across the east alignment, that you said that there was a slope stability issue. If you could provide that'd be...
Yep, potential.
Right, but I'm saying since we're doing a little bit more informative research, if you could provide some sort of information on if that's...
In the concept design report, we'll include a discussion section on why we need to set back from that slope and slope stability issue.
Or if you need to set back from that slope. I mean, it's possible that you don't. Or it's possible that you do. So, I mean, if you could just... go
Yes,
ahead.
we will address that in the concept design report specifically.
Thank you, Jesse. And then this paper that was given to us, are these questions that you were addressing?
Sorry
Go
about
ahead.
that. That was, these are questions that came up
Okay.
that were emailed to the city manager prior to this meeting, asking on design flows and costs for Los Osos.
Mm-hmm.
The Los Osos information came from the county public works director. I cannot pronounce Colt's last name, so I'm going to leave it at that. So it has what the monthly costs are, and then if you go down to the bottom of the page, you add the water costs to get the total cost for a variety of scenarios there in Los Osos. And then the bottom half of that table shows the collection distribution system costs, the plant costs, and the total system costs for Los Osos.
Los Osos. Okay,
Yes.
thank you.
Sorry about that.
Does the public have, do we have that? Whatever you're talking about? Agenda correspondence?
We have a couple copies of it.
See, typically, because of the Brown Act, we email questions individually, so that's why I was asking, were these questions from the members or just some additional information that could be included? But this is good info, and then include it in the, you have all our comments and everything, right? Okay.
Yes.
Thank you. All right, let's go. I'm going to start on the right this time to any other final questions or closing comments, please. Doug?
Richard mentioned the flow of whatever it is, 6.5 million, and here this one water plan says 8.1. I'm curious, what's the difference? What, I don't know what to think about this.
Yeah, so I need to dig into the specifics of the study that was done, the storm that was captured with that, and then also what storm we used to come up with the 8.14. So we did a flow monitoring during wet weather. In there, it will talk about the wet weather events that were captured. Again, the intensity and the a 10-year, 24-hour event or whatever storm was captured there, and what's represented there. We applied a certain design storm to the model to come up with the 8.14. The other thing that was taken into account in the model is there were several collection system improvements that were identified that needed to be done for a capacity consideration. So actually, when you start to do some of those improvements in the collection system, you can actually increase the peak flow that the treatment plant can see, because you're alleviating some of the bottlenecks in the system. And so part of that goes into that as well. So as you make improvements to the collection system, makes it more efficient to be able to move water through the collection system, and you can actually see higher instantaneous peaks with large storm events. So it's a combination of a number of those different things. I just need to go back and do a little bit of a forensics on the flow numbers that were initially published in 2007, the Montgomery-Watson numbers that were done in 2009. There were numbers that were done by Black and Veatch early on in the facility master planning process, and then the One Water numbers that are now being used by the designer for the lift stations and pipelines, as well as the designer for the on-site
I
facilities.
think that would be great, because there's still a lot of people who have different views of this, so it'd be nice to address that.
Sounds good.
Okay.
That's it.
Thank you, Doug. Richard?
From my experience as a grade 4 wastewater collection system expert who worked in Cayucas and was able to get FEMA funding for liquefaction damage, and that experience I had there, I would say that before we spend a dime more on any of this, we fix our collection system and get some accurate numbers. There's pipes that have been identified basically 15 years ago that needed to be replaced and are still still haven't been addressed. So I think that the focus should go from moving the plant. I deal with climate reality and climate change issues. And when you look at this project, is supposedly a climate adaptation project. And what we've taken is the sliver of sea level rise and applied it to a project that makes absolutely no sense from a climate change standpoint. We need to address climate change as an integral part. That's addressing greenhouse gases, have a wastewater resiliency plan like they have in New York. They're not moving a wastewater treatment plant. We also need to focus on getting our collection system fixed so we can get accurate flows and minimize the I&I and not waste money overbuilding.
Thank you, Richard.
My comment will be, I think the project needs a little bit of attention given to community disruption, scheduling, and traffic plans, and working with the Chamber of Commerce maybe, and getting the business community a little bit more comfortable with what we have forthcoming.
Thank you. Valerie?
Nothing.
Steve?
I'm good.
And Paul?
Yeah, I had one last concern, and it had to do with your mentioned pothole utilities. In my experience with federal involvement on projects is that even putting a signpost in may require a monitor. You don't want to jeopardize your federal funds on this job, so seeing that you haven't started the Section 106, this could be instrumental in getting the presence or absence of materials when they pothole, and just so that you don't jeopardize your federal funds by jumping the gun here.
Thanks, Paul. And Rob, can you comment quickly on where we are on the WIFIA loan application or any of that?
So the WIFIA application was submitted on time. It's being reviewed by EPA staff. We have regular coordination meetings with them. Right now, it's being assessed for being included in their program environmental. So all the WIFIA projects will have one environmental document that addresses them all that they're looking to take forward. So, and then EPA staff is coordinating with state board staff on the review of all the technical information.
Okay, thank you. Yeah, go ahead, Val.
Are you still working on the Bureau of Reclamation grant?
Yes, we have a document into Bureau of Reclamation, a crosswalk document that basically translates our master water reclamation plan into the what required for that Section 16. Title 16 grant application. So that's being reviewed.
So it's being reviewed. If you had any communications or any hints?
I think we have some corrections to make or clarifications.
Yeah, that document was submitted earlier in 2018 for the last round of Title 16 funding. The next round of Title 16 funding is going to come out is likely going to come out in January of this year. So we submitted that document previously. We have comments. We're addressing those comments, so that crosswalk document will be ready to go to them before that comes out. We also we've been notified by the state that our SRF application has been deemed complete, and it will be reviewed the 1st of January. So that process has changed a little bit in that it kind of has it used to be a rolling application, and now it's due by the end of the calendar year for projects that would be funded in the next fiscal year. And so that is in and complete, and they will be reviewing that in early January.
Good, thank you.
Okay, good. And then I think you have, if there's no further comments, everything you need from us. Are you taking this to the first city council meeting in January? Was it the 8th or the
Yes,
22nd?
basically this same brief report to get direction on alignment, lift stations, and then the concept design report would come back to WRF-CAC, the full completed final draft report, that first meeting in February.
Okay.
And then on to council that next week.
Okay, thank you. And then the only other comments before I adjourn the meeting is that for those citizens interested in being involved in any of the citizens boards, there are currently 14 openings in all of our various, not this committee at this time, but I think almost every other one, Harbor, CFAC, planning, et cetera, et cetera. So all the information is available on the website. Applications are due January 11th, Friday at City Hall. So if anybody is watching or here today and is interested in any of those particular boards, we would welcome your participation. So I'll adjourn the meeting, It is 5:06 PM. Thank you.